On this video, we're going to talk about binary, but specifically, we're going to start talking about negative numbers. Now, so far, we've managed to do whole numbers and positive numbers. So we can do, say, this number here is the binary representation for 12. I'll just focus that a bit. It's going to be out of focus. There we go. So this number here is the binary representation for 12, 1s, 2s, 4s, and 8s. Okay, nice and simple. But what if we want negative numbers? Well, there's a couple of ways we can do negative numbers. And the easiest one probably is sign and magnitude. Now, with sign and magnitude, all we do is we say the most significant bit, so the one furthest to the left, indicates the sign, and the other bits indicate the magnitude or the size. So if you're talking binary numbers, if we say minus 12, what we're saying is this bit here is the sign, and this bit here is the magnitude. Okay, so the first bit in binary tells us whether it's positive or negative, and the second section, everything else, tells us how big the number is. Exactly the same works with sign and magnitude in binary. So if I had plus 12, and for argument's sake, let's say I'm storing it as 6 bits. Okay, so there is plus 12. Okay, the most significant bit, so the bit furthest to the left, represents the sign, and everything else represents the magnitude. And so if we want to make this minus 12, all we do is say the magnitude is still 12, but the sign is the other way around. It's minus 12. Okay, so plus 12, minus 12. And all you do is you look at the sign, you look at the magnitude, and it works very much like binary numbers. Okay? Now, if you're studying for OCR computing, you definitely need to know that. For AQA, you probably won't need it for certainly the AS exam. But it's useful to know. It's kind of a historical explanation for kind of how we get from whole numbers to negative numbers, because there are other ways as well. But if you understand the principle of the first bit's for the sign, everything else is the magnitude, you should be okay. We'll do a couple examples. If I said, I've got this number here, what does that represent in binary? In binary, sorry. Then the most significant bit is the sign, so it's positive. And then we've got, what have we got? 64, 16, and that's 10. 6, 7, 8, 9. That's plus 90. If I wanted the negative version of that, I'd just swap that to a 1. You don't need to draw those dotted lines in. That's just for me to kind of demonstrate what I'm talking about. So that'd be minus 90. If I had another one, then again, the most significant bit for the sign means it's negative. And here we've got 32 and 16, that's 48. And here we've got 2 and 4, that's 6. So we've got 54. So this number is minus 54. Okay, so the most significant bit, wherever it is the sign. Everything else is the magnitude. Dead straightforward.